I can start the session, sir. I can start the session, sir. I can start the session, sir. Hello, good morning, everyone. So I'm very happy and very glad and very excited, to welcome everyone, each and everyone who are on live. So we are going to discuss today the second part of separation of substances, right? If you remember, day before yesterday we discussed the first session, that is on separation of substances, right? Now today we are going to discuss second part of it. Okay. So hello, good morning, everyone. Let us start our session. I'm very happy and very glad and very excited, welcome everyone, each and everyone who are on live. So just quickly, I'll share the screen with everyone. Just give me a minute. Fine. So here we go. So before starting the session, I just wanted to introduce again those who are new, right? So we are the team of Swiflearn, who is India's most sincere learning destination for classes 3 to 10, right? And we have this main 4 features presented especially for you. The first is 100% live and interactive classes, right? Like now the live class is going on, you can interact with me as well, right? You can write whatever questions or doubts or anything, whatever comments you want to share on the chat, live chat, right? Second thing is personalized attention batch with maximum of 6 students, only 6, right? Why? Now you may ask, sir, why only 6? We should have more. But see, when we have more number of students, then what happens? The personal attention, exactly, personal attention with the students is not much efficient, right? So we have limited our strength of class is only up to 6 students, right? So that we can give more and more personal attention to each and every student, right? Third thing is a dedicated academic mentor team to track and work on students' progress. See, the progress of you is what our ultimate goal of teaching is, right? So we want you to progress in your academics. If your results are good and if you get the top results, right? So that's a great achievement for us. So we, the dedicated team of academics, are really focused on growing yourself in academics, right? That's the third thing. And fourth thing is we cover entire syllabus, course all syllabus as per the school exam schedule, and also handle custom requests, right? So whatever exams you are being conducted in your school, based on the same exams, we conduct practice sessions, right? And we cover entire syllabus, whatever is syllabus, whichever board you belong to, either it is CBSE or ICSE. That's what. So these are the main 4 features you have to remember, and you have to join our regular sessions. Okay, so see you in your regular session, in our regular sessions as well, right? So now our more important key features, as it is mentioned here, detailed progress reports, right? Now how much you have progressed, how much you have come so far to achieve the success, we would like to know, right? As well as your parents and you also would like to know, is it not? So we give a regular progress reports, right? Second thing is SATs, that is called a Swiflearn academic test series. We conduct regular test series, right? To check your knowledge, to check your scoring, to check how much you are able to understand, how much you are able to perform well, right? So this is what we do. The SATs, we do that. Swiflearn academic test series we do. And third thing is test, take unlimited practice tests. You know, there is a saying called as practice makes man perfect, is it not? You must have heard that, but practically we do that, right? We take so many practice tests so that you achieve the perfection in your academics. And the last thing is subjective test for school exams as well, right? In your school exams, you have subjective exams. So based on subjective exams, we also conduct subjective tests on the Swiflearn platform, right? So please book a free trial class and please join our regular classes if you are so much excited and happy learning and on the Swiflearn platform, right? Okay, before going ahead, I would like to request each and every one of you here present, please subscribe our channel, and please don't forget to press on bell icon so that you don't forget any of our live sessions, update live sessions, right? So please do that right now. If you are not subscribed, please subscribe that, and please press the bell icon. Okay, thank you. So let us start now. This is our second session, separation of substances, right? Okay, before going ahead, those who are new, I'm going to just quickly revise also. Don't worry, don't be in tension. So we missed the first session, no problem. I will revise whatever we discussed in the first session, and then I'll go to the second session. Okay. So separation is what? Separating the objects, 2 objects form a mixture, right? Mixture is basically substance which comprising of various components of material, right? As you can see here, this is your mixture, right? It has coarse grains and small grains as well. So you use this filter, and with the help of this filter, you separate out the coarse grains and small grains. That is what is separation is. Okay. So let us, what we are going to discuss today, right? So these are the main points. Define sedimentation, right? Decantation, filtration, define evaporation, describe how we can use more than one method of separation. Right, there are various methods we discussed last session, but there can be more methods also that also will be discussing. Explain the process of condensation. Condensation, the process we'll discuss. Define saturated solution. What is saturated solution? That also we'll discuss. These are factors that affect the solubility of substance. You know, solubility. What are the factors which affect solubility? That we'll discuss. And then the things can be dissolved in water. List the things that can be dissolved in water. Which are the substances which dissolves in water? Of course, you might be knowing few of them, right? So that also we'll be discussing. Okay, fine. So let us start. Everyone is ready, right? Fine. So in the previous class, we have studied about the separation of different substances from their mixtures, right? So these are the two examples as you can see in this slide, right? This is called as thrashing, right? Thrashing means what? Taking what? This, yes, rice paddies and hitting over the strong surface. That is what. And this is another lady you can see here. She is, filtering or separating the coarse grains, sorry, the stones, small stones from the rice, right? That is also there. So what is separation first of all, right? What do you mean by separation? Anybody would like to give me the answer? What do you mean by separation? Yes, exactly. Separation means what? Separating two parameters from each other, is it not? Separate. What do you know? Separate. We use this word in our day-to-day language. Separate. Separation. That's what the word separation has come from. Separate, right? So separate means what? Dividing the objects or separating from each other, right? The process of separating one or more substances from a mixture is called as what? A separation. From a mixture, if you want to separate, then it is called as separation. Mixture is what? What is a mixture? Anybody? What do you mean by mixture? Mixture. Any example? Okay, yes, correct. Mixture means basically combination of one or more substances. Very good, very good. So mixture is basically what? Combination of so many substances, right? Any example you can give? Example of mixture. What can be the example of mixture? Yes, very good. Mixture, basically what? Yes, very good. Like you have this example as it is given. What? You have the rice and you have the mung dal. You can add together. That becomes a mixture. And when you want to separate rice and mung dal, yes, you can separate that. That is a separation, right? So that is what is called a separation. So separation is the process of separating one or more substances from a mixture. It is a process. Which process it is? Separating one or more substances from what? A mixture. Simple definition, right? So you have to remember the conceptually. All the things you have to remember conceptually. Don't by heart the things, right? If you understand conceptually, it's far easy to remember the things. But if you by heart, within a fraction of a second, you may forget the next sentence or next word, right? So never trust on by hearting. Understand conceptually, logically, and then remember. You will never forget. Is it not? So what is the separation? The process of separating one or more substances from a mixture is called as separation. Okay. So why do we need to separate substances from their mixtures? First of all, what is the need of separation? Yes, anybody? Why do we need, first of all? What is the need? Yes, exactly. Because I want to separate pure and impure things. Like simple example as I discussed, right? Rice has a small stones and which are harmful for our digestion system, is it not? So these unwanted things you want to separate from the rice. That is what the need is. So what is the need of separation? Because I want to separate impure and pure things, right? Or the useful and useless things, right? That's the main purpose of separation. Very good. So these are the needs: to remove useless or harmful substances. That's the first need, right? Second is to obtain pure or useful component. Whatever pure thing is there, I want to use it, right? That is the second purpose. And third purpose is to remove impurities. I want to remove the impurities. That's the third purpose, right? Is that clear? So these are the three purposes you have to remember. First is to remove useless or harmful substances. Second is to obtain pure or useful component, which has to be used practically in our life. And third thing is to remove impurities so that I can keep the pure substance as it is, as pure as possible. So these are the three purposes of separation. Very good. Let us go ahead. Now, list some methods of separation that we have studied in the previous class. Anybody can recollect, those who are present? What are the methods, different methods of separation? We discussed that. Yes, very good. That's correct. Very good. Thank you. Right? Separation, there is a thrashing, right? Then winnowing, then sewing. Very good. Very good. That's correct. So these are the different methods we discuss, like this: hand picking, thrashing, winnowing, sewing. Very good. Right? So these are the main 4 basic methods of separation. Okay. So these things you have to remember. Can we separate all the type of substances by using only these methods, or we can use other methods as well? Okay, fine. I'll just briefly tell you about all these 4 things. Hand picking. Hand picking is the first. I'll give you a simple example. Like, you have the bag of or basket of fruits. In that, mango, apple, and chiku are there. Okay, which one is your favorite, by the way? Mangoes. Very good, right? And everyone likes mango. It's a king of fruit, right? So what you'll do first, you'll take out the mangoes, right? You select and take out the mangoes and keep it aside, right? Then what you'll do, you'll take apples and keep it aside. Then what you'll do, you'll take chicos, or we need not do that, because apples and mangoes are removed. Then what is left off in the basket, that's chiku. So this is called as the method or process of separation. Which process? Hand picking separation. Understood? Example? Very simple. Then threshing. Threshing is what? I'll give you an example of this. You can see this in this first picture. These farmers are what they are doing. They're taking this rice paddies and hitting, threshing against the harder substance, right? Because of that, what happens? Whatever the rice particles are there, that is getting separated. Very good. This is called as threshing. Then next is what? Winnowing. Then next is sieving, right? What is winnowing? You see this same example. This lady is doing winnowing, right? Winnowing means what? Taking out the lighter and heavier particles from each other. Very good, correct. So what we do is, as you can see, this lady, you take the rice paddies, right, with the skin, rice with the skin, right, and you hold it in the air, right? So let's say the direction of air is like this, right? You hold it like this, right? So all the heavy particles will fall ahead and all lighter particles will fall behind. So whatever the useless particles are there, right, which are having the lighter weight, will fall near our leg, right, and the heavier particles will fall ahead of our leg. So this is called as winnowing. Is that okay? Winnowing. Everyone understood? Right. And the last one is sieving. What is sieving? Yes, anybody can tell me the very famous example I discussed in the last class. Anybody would like to say something? Sieving. Yes. Yes, very good. Your mother making a tea. Yes, correct. So nowadays it's a cold season, right? So everyone needs something hot as soon as they get up, right? So when you get up, you wash your mouth, have a nice clean, teeth, and then what do you request to mother? Or even if without requesting, mother brings a cup of tea. So while making the tea, what mother does? She separates the tea leaves from the tea. Exactly, very good. So that is called as sieving, right? Another example is flour. Like we have wheat flour, java flour, whatever the flour we have, that we separate it by filter. That is sieving machine or sieving object, right? Sieving device also we call it, right? Small sieving device also we get. So that is what is called as sieving. So these are the main 4 things that we discussed in the last class. Now let us proceed ahead. Can we separate all the type of substances by using only these methods, or there are some other methods? Okay, let us see if there are some other methods. Nice. Now, for example, rice and pulses are washed before cooking. You must have seen your mother washing them very thoroughly, right? 3-4 times, I can say. When we add water to these, impurities get separated. These impurities go into water. Now, what will sink to the bottom of the vessel? Pulses or impurities? Yes. Have you observed this? Your mother doing in the kitchen? She takes the rice and pulses and she keeps on washing again and again, probably, of course, 2 to 3 times. And observe carefully or remember carefully what mother does. She carefully take out the water, right? And as soon as water is coming out, whatever the grain is there, she takes out into a good vessel, clean vessel. And the last part, whatever is there, is your impurities. Very good. So when you put water into rice or pulses, what happens is, what sinks at the bottom of the vessel? That is called as pulses or impurities, isn't it? Correct? Why the vessel is tilted to pour out the dirty water? You must have seen that. Your mother. Very good. Some of you are nodding. Correct. So sedimentation, that is what the process is. Sedimentation is another further process of separation. Very good. So as you can see in this diagram, this is a big vessel, as you can see this, right? And this is the clear water, the blue, plain blue, right? And the water containing insoluble impurities. Insoluble impurities are these dots, right? Chocolate color dots. And insoluble impurities are lying down, right? Collected down at the bottom of the vessel, right? So the process in which the heavier particle in a mixture settles down after water is added to it is called as sedimentation. This definition you have to remember. Huh? Please repeat after me. The process in which the heavier particle in a mixture settle down after water is added to it is called as sedimentation. Very simple definition, is it not? So what is the process is, you take a rice, as it is the example given, rice or pulses if you take, right? Add water, then what happens? Whatever the impurities are there, or the heavier particles are there, that settles down, and carefully you take out the water by tilting the vessel, right? So this is the process of sedimentation. Everyone is getting? No problem? Any doubt? Fine, very good. So that is what is called as sedimentation. Very good. Let us go ahead. So this is, yes. So decantation or decantation. What is this? Superintendent. What do we do with this? These are the sediments. You can see this blue color is, yes, superintendent, and this is your chocolate color is your sediments. So after setting down of particles at the bottom, the water along with the dust is removed. This is called as decantation. Very good, right? So what do we do? Whatever the impurities are there, they settles down, right? And then what do? You till the water or till the vessel, and then the pure water which is on the top will come out, and whatever is left off in this vessel, second vessel, as you can see this, are your impurities, which is of chocolate color, right? Impurity colors. Very good. So this is called as, yes, decantation, right? Now, do you know we can use the same principle to separate the mixture of two liquids that do not mix with each other? Example, oil and water mixture. You remember this? We discussed this example, right? Very good. So oil and water, if you try to mix, what happens? The oil rests on the top of the water and the water is below, isn't it? And there is a separation. You see that water doesn't get dissolved into the oil, correct? So we can use the same principle to separate the mixture of two liquids that do not mix with each other, right? So if, let's say, there is oil on the top of your water, what do? You just fill the glass, right? And take out the oil which is on the top layer in another vessel. So oil and water separated. Simple, is it not? It's as simple as that. You can also do that practical. After this class, also you can do that practical, right? Everyone is home in the home right now, right? Due to lockdown. So you can do this practical experiment, right? So if such a mixture of such liquids is allowed to stand for some time, then they will form two different layers. Then the component of top layer can be separated by, yes, decantation. Is that clear? Decantation is clear? Any doubt? Very good. Thank you. So next process is filtration, right? Next process is filtration. What we discussed first thing? First we discussed about, yes, yes, this is the first thing, right? That is called as decantation. This is sedimentation. Sedimentation is what your all the impurities are settling down. Then, yes, this is decantation, right? Till the vessel and take out the pure substances which is on the top, and whatever rests down is your impurities. Now the third one is filtration, right? So you must have done that in your science lab as well, right? So this is filtration. So what is this process? Let us discuss. It is a process of passing the mixture through a filter to remove the insoluble impurities from the fluid of the mixture. So what do we do in this process? Right? There is a filter, or this is you are able to see this cone shape, right? And there is this small tube below, right? So this is called as filter. So this mixture, which is in this beaker on the top, has to be filtered. So what I do, I take this flask, okay, and at the nose or at the mouth of this, I put a conical flask, right? Then whatever the mixture is there, right, which I have to filter, I collect it in the beaker and then pour it through this filter. And through this filter, what happens? It is get collected here. So whatever the impurities are there that are lying at this conical flask, very good, right? Example: filtration of tea leaves from tea by using a strainer, or filtration of muddy water through a fine filter to get clean water. You must have seen that also. This is a very famous example. Your mother making a tea, right? So that is a sewing also, same process basically, right? It's not much different than that, right? So this is how filtration we do. That is tea leaves from tea you can separate, or muddy water, right? So if you want to remove the mud from the muddy water, use this filtration, right, to get the clean water. So these are the two examples. Okay. Then next is evaporation. Evaporation must have seen everyone, right? So what is evaporation now? It is a process in which the liquid changes into gas is called as evaporation. You must have heard this word before also, evaporation, right? So evaporation is a process in which, yes, very good, the water starts boiling. If you take example of water, very good. This method is used to separate the mixture of common salt and water, right? If you want to separate out salt and water, if you remember last class we discussed, when you add salt to the water, you cannot separate it out so easily. But here is a method given, right? So evaporation is a process by which we can separate the salt and water. You can separate easily. So this method is used to separate the mixture of common salt and water. In this method, the mixture is heated. The liquid part of the mixture gets evaporated, leaving the solid part behind, right? So generally what happens in heating process, I'll give simple logic, science behind this. So when you heat a material or any liquid, let's say water, right? So whatever impurities are there, they get little more heat. They require little more time to heat, right? And these are the heavy particles, right? So heavy particles, what happens? Heavy particles settles down, and the lighter particles go up. Right? Same case is happening here. The liquid part of the mixture is there, that is of lighter weight, that gets evaporated. Whatever the solid part is there, that settles down, right? So this is how you can separate the salt and water. You can do this experiment as well in your home. It's very simple, right? Now, next is, did you ever observe water drops under a plate that has been used to cover a vessel that contains boiled milk? How does it happen? Yes, have you observed this? Yes, anybody? Plate that has been used to cover a vessel that contains boiled milk. Yes, you have observed? Very good. Some of you are raising the hand. Very good, thank you. So these water drops, how it has formed, right? While putting the lid on the hot milk, on the vessel of the hot milk, have you seen? You can just see on the other side, are there any water droplets? No. But when you put it and come after probably 5-10 minutes or even 15 minutes and open the lid and you see the water droplets, isn't it? Which are there on the backside of lid, right, or the cover, right? How does it happen? Now I want answer from any one of you. Yes, anyone would like to give me the answer? Does it happen? Yes, correct, very good. So because of, as this example is related to the previous example as we discussed, right? Evaporation, very good, right? So how does it happen? It is the process of conversion of water vapors into its liquid form. This process is called as condensation, right? This also you must have seen. You take, especially in summer season, you keep a hot water, oh sorry, water in the freezer, right? And then what happens? After a few hours, if you take out the bottle, then you see this, water which is assembled on the surface of the bottle. That is what is called as condensation. Right? So it's the same process. This process is basically conversion of water vapors into its liquid form. So water vapor converts into liquid. So temperature increase or decrease? Anybody? In condensation process, temperature increases or decreases? Yes, very good. Correct. In condensation, temperature decreases, right? Temperature decreases. And in heating process, of course, temperature increases. So condensation is a process in which also temperature is reduced of the material or of the substance, right? So that is the process. Condensation is what? Conversion of water vapors into its liquid form. Okay, fine. Now, next is, do you know sometimes one method is not sufficient to separate different substances? Is it not? Have you seen that? Let's say if you take some particular example, right, and you've done any by using any of the separation process we have learned till now, and if you do that separation, but that is not sufficient enough to separate the things. So in that case, what do? More than one method are used for the separation of substances, right? Till the time you get pure substance. How long you have to keep on doing this separation? Till the time you get pure substance. Once you get a pure substance, yes, then I can, very good, then I can stop the separation process, isn't it? Correct. So now the question comes, how will you separate the mixture of sand and salt? Yes, the first thing what I'll do is keep the mixture in a beaker, take a beaker and keep that mixture into the beaker, add some water and leave for some time, right? Then what happens? Come after some time, probably after 1 hour or 2 hours, right? What happens after that? After settling down, the sand can be separated by filtration or decantation, right? So when you come after some time, as you can see this in this diagram, this is the first case in which you have, case you have this beaker. Very good. So this beaker is there. In that, what is there? Here, mixture of water and mud. Very good, right? Or the sand. So this is a mixture of water and sand, right? Just keep it in the keep it some corner of your home, and then come after some time, probably a few minutes or after half an hour. What happens? Then this beaker, yes, as you can see this, after some time you come and see this, you see this at this down portion, what is there? What settles down? All the sand, right? And whatever on the top is there, that's a pure substance is available. So whatever the impurities are there, those all impurities will be settled down. Are you getting this? Right? Is this simple? Any doubt in this? Simple to do that. In fact, you can do this experiment as well. See, I'm telling you so many experiments which you can practically do right in home, right? So you can make a learning process very, very joyful, isn't it? And everyone must have experienced this. When you learn something, and if you apply that, if you do something practical, then you get a lot of interest. How many of you? Yes, everyone? Correct. Very good. So learning process becomes very, very joyful when we do something practical. So you see, so many examples I gave you till now. You can do them practically at your home. So your home, you can make it as a laboratory, science lab. That's amazing, right? So how will you separate the mixture of sand and salt now? The next procedure, next thing, this descended liquid contains salt. Now we need to separate this salt. Earlier case it was mixture of salt, water and mud or sand. So in the first process, what we separated, this is your blue color, what you are able to see, that is your salt water, and whatever is down is your sand. So first you separated the sand. Now I want to separate the salt water is there. I want to separate salt from the salt water. So what do we do? That What do we do for that? Transfer this liquid into a kettle and heat the kettle. You know the kettle, especially now in the cold season, people use, right? Because they want to drink hot water, isn't it? So for drinking hot water, we use a kettle. Kettle is actually it is a vessel which is connected with the coil, electric coil, and that has a plug. You know, when you put it into a plug switch at your switchboard and you on, then it heats. There is a coil at the down, right? Electric coil. The electric energy is converted into heat energy, and then because of the heat of the coil, what happens? Whatever the substance is there, especially water in this case, water gets heated up. The temperature of water increases, right? That is called that is the kettle, the process of kettle, heating of the water through the kettle. That is what the explanation I gave you. Okay, so transfer this liquid into kettle and then heat the kettle. Then what happens? After some time, you can see this third. After some time, the water gets evaporated, leaving the salt behind. So whatever is left off, right, after some time is your salt, separated from salt water, right? So this is a complete process. I hope this is clear. The process is clear. So with the two methods of separation. First is decantation and second is evaporation. Very good, very good. Thank you. Any doubt so far? Anybody has any doubt? Everything is going on well? Fine. So let us go ahead. What happened? Okay. In the above mentioned example, we have dissolved the sand and salt in water. Can water dissolve anything in any amount? Yes, is that possible? Just think about it. Just now, whatever example we discussed, right? Sand, salt is added to water. Now the question comes, can water dissolve anything in any amount? Can water dissolve anything, any substance into the water at any amount? I can take large quantity, 1 kg also I can take or 10 kg also I can take. Is that possible? Yes, is a question for everyone. Anybody? Can water dissolve anything in any amount? Yes. Correct. Very good. No, it's not possible. It depends on the quantity of water and quantity of substance what you are going to dissolve into water, isn't it? So it depends on the quantity. So now we know that many substances can dissolve in water and form solution. These substances are soluble in water. But what will happen if we go on adding more and more substances to a fixed quantity of water? I'll give a simple example. Right? Take a glass of water. Okay. And half fill it. Let's say it is 250 ml of gas and half fill it. How much it is? 125 ml. Okay, take a teaspoon of salt, add it, maybe 10 grams, right? You add it, gets dissolved. Yes, water can dissolve the salt. Take another spoon, keep on adding. And let's say you added half kg of salt. Where is the water now? Water is invisible, water has gone, right? So you're adding, yes, 500 gram of salt into how much? 120 ml of water. That is not possible because water quantity is fixed, what it says here. But what will happen if we go on adding more and more substances to a fixed quantity of water, right? What will happen? Then it will not dissolve, right? So the same example is given here. You can see this. If we keep on adding more and more substance to a fixed quantity of water and stir, it will every time. We will notice that after some time, no more substance can be dissolved, is it not? So whatever the quantity, okay, the salt what you're adding, it can be dissolved till, let's say, how much amount of water was there? 120 ml, 125 ml, right? So it may take up to 100 gram, right? Or it may take up to at the max 110 or 120, but more than that, it cannot. That is the excess amount of salt you're adding to the water. So water will disappear. Water doesn't have enough capacity to dissolve large quantity of salt, which is more than the quantity of water. The condition here it is what? The quantity of substance you are adding is more than the quantity of water. Then in that case, it cannot dissolve, right? But in the all earlier cases, like, if you're adding a teaspoon of salt, yes, in the 150 ml of glass of water, yes, it can dissolve, right? So that is a simple explanation. Is that clear, everyone? Right? Fine. Saturated solution. Now let us discuss about the saturated solution. What is the meaning, process, or the definition? The solution in which no more of the solute can be dissolved is called a saturated solution, right? So whatever example we discussed, right, salt and water, when you add excess amount of salt into small quantity of water, that is called a saturated solution, right? So now in this, there are two things. One is a solvent and the second is a solute. So what is a solvent? Solvent is the water particles. As you can see this, water particles. And what is a solute? Solute is your sugar or salt particle, right? Solute is that substance which dissolves into the solvent or the water particles, right? So who is taking? The water is taking the role of dissolving, right? And solute is your sugar or salt, whatever it is, like that. Okay. Now the fun fact. What is the fun fact? We can increase the solubility of solute by heating the solution, right? If you want to increase solubility of any substance, how do you do that? Just give a heat to the substance. The quantity of a substance that I can dissolve in hot water is much more as compared to that in cold water, right? So this fun fact you have to remember, right? So what is the fun fact? If you want to increase the solubility of any substance, what do? Just heat it. Heat the substance. And after heating it, what happens? The solubility increases. Is that clear? Very good. Now, what are the factors affecting solubility of substance? Let us discuss that. Right? Factors. First thing is stirring. Stirring means the process, right? You take a half glass of water and put a teaspoon of salt and you keep on stirring. So this is a factor. Stirring is a factor on which your solubility of substance depends. Sugar dissolves faster than the solution is stirred, right? You take a half glass of water and add a teaspoon of sugar. So if you keep on stirring it, the solubility increases, right? Second factor is solute in powder form. Instead of grain sugar, granular sugar, if you make it into powder, sugar in powder form dissolves faster as compared to sugar cube. You must have seen that, right? You can compare also, right? You take a glass of water, 150 ml glass of water, put sugar cubes, 1 teaspoon, and take the same sugar cube and make it a powder through a mixture. You have a mixture in your home, in the kitchen. Make a powder and take another glass and the same quantity of water, that is 150 ml, and put the same sugar powder, what you have made, the same quantity as it has been put in the first glass, and keep on stirring with the both hands. Which one will dissolve first? First or second? First one you have put sugar cube and second one you have put sugar powder. Yes, anybody would like to give the answer from the audience? Yes, very good. That's correct. Which one will dissolve? One, the glass in which the sugar powder is there. Very good. The sugar powder has larger capacity to dissolve. Sugar powder gets dissolved into water more easily than the sugar cube. Very good. Right? Different substances dissolve in different amounts of water while making a saturated solution. So depending upon the different substances, different amounts of water can be used for dissolving a particular substance. Okay. So we have discussed various methods of separation in this chapter. Some of the methods can be used in science lab as well. Method not. Whatever methods we discussed till now for separation, that can be used in lab also, your science lab, right? So that is what we can do. Okay, so here we end this session. Now it's a quick revision, right? So I want to answer from audience now. Checkpoint, question and answer. What is evaporation? Anybody? Anybody would like to tell me? What is evaporation? Evaporate. Yes, anybody? Or you can tell me, in case of evaporation, what happens? Temperature is increased or decreased? That also you can tell me. Yes, very good. Evaporation is a process in which what? Yes, you heat the substance, right? To separate out. Can anybody tell me which is the example we discussed in case of evaporation? Example for evaporation. Yes, very good. Salt water. Very good. If you want to separate the salt from the salt water, what do? We heat the salt water, right? Then eventually salt will be left out, and the water gets evaporated into the air. That is correct. So in the process of evaporation, temperature is increased or decreased? Of course, increased. Very good. Next question is define condensation. What is condensation? Condense. This condensation word comes from condense. Yes, anybody? If you want, I can give the hint. Should I give the hint? Yes. Hint is we discuss the example of boiled milk covered with the lid. And as soon as you open the lid, on the back side of the lid, what you can see? The water droplets. Very good. That's correct. That is a condensation process, right? So condensation process is a process in which converting water vapor back into liquid. Simple. So temperature increased or decreased in this case of condensation, not evaporation. Sorry. Condensation, temperature is decreased. And evaporation, temperature is increased. Very good. Okay. Next question is differentiate between sedimentation and decantation. This we discussed in the beginning of our today's session. Sedimentation and decantation. Anybody? Sediment, descent, sedimentation and decantation. Yes. Yes, very good. Sedimentation is what? Very good. When you add the water to the muddy water, right? If you want to separate any impurities from the substance, what do? Just add water to it. Then whatever the impurities are there, that will settle down. That is called a sedimentation. And what is decantation? Decantation, what do? Whatever the pure substance has come out, right, on the top, just separate it by tilting the vessel and pour into another vessel the pure substance. That is called a decantation. Very good, very good. What is filtration? Filtration? We discussed this very famous example also. Filtration. Anybody? Filter. The filtration word comes from the filter. Very simple. That's a logic or science you can apply behind it. Filter. What is the meaning of filter? Try to recall what is filter. You'll get easily definition of filtration. Filtration. Yes. Correct. Very good. Filtration is what? Basically filtering the substance. The famous example as I discussed is, yes, your mother making a tea, right? While making a tea, what she does? She takes out the tea leaves from the tea with the help of filtration device. That's correct. So these are the answers. The process of conversion of water into water vapors is called as evaporation. Okay. Water into water vapors. By heating, of course, you have to give the heat. Then the process condensation is what? Sorry. Yes. The process of conversion of water vapors into water drops is called as condensation. Right. Very good. That example we discussed, right? When you heat the milk, when it is covered and you come after for some time, then what happens? If you open the lid, you can see at the back side of the lid, there are water vapors. Water droplets, right? So that is basically a process in which water vapors are converted into water drops. That is condensation. So in that case, temperature is decreased. Very good. Next, I asked the question about sedimentation and decantation. Sedimentation is what? The process in which the heavier particle in a mixture settles after water is added to it, right? So when you add the water, right? So what happens? Whatever the heavier part is there, that settles down, right? And the upper portion or the upper part is your pure substance, right? So after setting down the particles at the bottom, the water along with the dust is removed, right? This process is called as decantation. Very good. Correct? That is called as decantation. And the fourth question was, it is a process. Yes, filtration definition, right? Correct. It's a process of passing the mixture through a filter to remove the insoluble impurities from the fluid of the mixture, right? So whatever the mixture is there, which is a fluid, right? We want to filter it. So what do? We allow that substance to pass through a filter. Then what does filter do? Filter separates out The impurities, very simple, right? So this is the homework. I will give that homework. First, I'll just go behind and discuss whatever we discussed till now. Okay, just quick revision. So hope everyone has subscribed, those who have joined till now, and not forgotten to press on the bell icon to not miss any of our live sessions, right? So this is what we discussed: sedimentation, decantation, and filtration. Then evaporation we discussed, right? And then we discussed about more than methods what we discussed in the last class: separation methods, process of condensation. Then we discussed saturated solution, and the factors which affect the solubility of substance, and then the things that can be dissolved in water, right? So need for separation, what was the need? Three needs. First is remove useless or harmful substance. Second is to obtain pure substance, and the third is to remove impurities. These are the three needs. We have to remember these three needs, very, very important. Okay. So these are the four methods we discussed in much detail in the last session, and I discussed this very in a short: hand picking, threshing, winnowing, and sieving. Right. So we discussed a few more examples of separation in this. Right. As I discussed example of rice and pulses. Right. When it is washed before cooking many times, right, 2-3 times, your mother does that. You can observe that in the kitchen today, right? After the session, your mother must be cooking now, so you can observe. You can ask also, what is the need to wash the grains or pulses again and again? To remove the impurities, because water collects all the impurities, right? So that is called as sedimentation. Okay, so when you add water, impurities will settle down, right? And whatever on the top is your pure substance, that can be removed out. That's what insoluble impurities in clear water, right? Then once you get this clear water, what do? You take this another vessel, tilt this vessel mixture into the empty vessel, and whatever is on the top, just collect it, and whatever is at the down, as you can see this chocolate color, that is your impurities, right? That is decantation process. Okay. Now next we discussed about filtration. Very good. With the help of conical flask. Yeah, this is called as conical flask shape filter. This is right that we discussed. Example of filtration is separating the tea leaves from the tea by using a strainer or a filter. Correct. Then next we discuss evaporation, the process of heating the substance. Right. That is evaporation. The liquid changes into gas. In due course of heating the substance, what happens? The liquid changes into gas. That is evaporation, right? And this we discussed about condensation. Very good. The example, correct. Condensation is a process in which the water vapors, conversion of water vapors into liquid, back to liquid, right? So if there is not a single process sufficient, then we use sequence of processes. We discuss example of salty water and mud mixture separated from pure water, salt, and mud. The first process we use is which one? Sedimentation, then decantation, then evaporation. Very good. So this is a series of sequence of processes. We discussed that, right? Then you can heat the substance also, whatever the quantity is there, and then you can increase the solubility of that, right? Saturated solution. What is saturated solution? When you add excess amount of salt to a fixed quantity of water, what happens? Water recedes to its peak value or maximum value of solubility, right? That is called as saturated solution. Further point of that, you cannot add any more salt. It will simply, yes, disappears the water. Very good. So this is a fun fact. If you want to increase the solubility, what do? You heat the substance, right? What are the factors? These are the two factors we discuss. Stirring. As you keep increasing the process of stirring, the solubility increases, and solute in powder form. If you add the soluble or solubility, if you want to increase the solubility, what do? You add the solute in which form? Not in the grain form or the cube forms, in the powder form. Then the solubility increases, right? So whatever we have discussed, you can do that in your science lab, as well as I mentioned, now science lab is not there in a school right now. The schools are shut off, right, because of the pandemic lockdown. So you can do all these experiments in your home itself, right? So whatever you have learned just now, you can immediately do the experiments in the kitchen right itself, in the home, right? So all the best, please do that. Then you experience greater joy and happiness in learning this subject matter. Okay, then we discuss these 4 questions. And this is a homework for you. How will you separate the mixture of sand and water? You have to answer it. Okay. Second question, how will you obtain the clear water from a sample of muddy water? Or you can explain the process as well. Which process you will use? We discussed that in the today's session. Which method is used to obtain the salt from seawater? That also we discussed. Right? These are all practical examples. What is saturated solution? That also discussed definition. And how can we increase the solubility of saturated solution? These are 5 questions as a homework. Take home and please solve. Right now you're in home itself, right? But before we go to the next session, right, I want answers of this. Okay, fine, thank you. So this is what we have learned today. Sedimentation, decantation, filtration, evaporation and condensation, use of more than one method of separation. What is saturated solution? Definition we discussed. Factors that affect the solubility of substance. And lastly, list a few things that can be dissolved in water. These are the things we discussed. Thank you so much. Okay. Okay. So please do not forget to subscribe our channel and press on bell icon so that you keep on getting updates about our live session. Thank you. So hope you enjoyed this session and are waiting and more excited to join our next session. So meet everyone in the next time. So everyone, please till then take care. Be at home, be safe, take care of your health, and by using Swiflearn platform, which is online teaching. Thank you. Thank you for joining with us. Thank you. So I'm ending this session here.